Today's speaker is Karen Simpson. In 1987, she commenced the Summer Research Scholarship in the Engineer and Water Supply Department and the Australian Centre of Water Treatment and Water Quality Research at Bolivar. On completion of her Bachelor of Science with honours, she conducted research into the disinfection byproducts in Australian drinking waters. This led to the establishment of the commercial accredited tests at the Australian Water Quality Centre, which now services customers from as far away as Singapore and Hong Kong. In her current role as Senior Manager, Laboratory Services at the Australian Water Quality Centre, Carolyn is responsible for the provision of high-quality analytical services to a wide base of national and international customers. Her focus on driving service and technical excellence across the Australian Water Quality Centre supports the water industry in the deliverance and assurance of water quality and, most important, public health. I give you Karen Simpson.
Thanks, Tom, and good afternoon, everyone. And thank you, Tom, for the opportunity to come here today to talk a little bit about what I do and what the Australian Water Quality Centre does. Just bear with me while I bring up the presentation. Okay, I think we're all set now. Okay, thank you. So today I'm just going to talk a little bit about what the Australian Water Quality Centre does. So the AWQC is SA Water's laboratory for testing water, but I'm going to go into a little bit of background as well on the development of our water treatment plants, a little bit of the history around that and how the laboratories have evolved over that time. So water, I think we all agree, is a very precious resource, and we can take it for granted. We turn the tap on and we have there a clean, very safe product, and that's not the case for all parts of the world. So it's a readily available supply of water that we have, but it hasn't always been that easy. So a little bit about our history. So if we go back into the 1800s, it was really critical for the settlers in this state to actually find reliable sources of water. The River Torrens back then was relied upon quite heavily for the settlement of Adelaide, but it wasn't used just for drinking water purposes. So it was used for watering stock, for bathing, and even disposing of rubbish and sewage. So I think you can imagine that there'd be all sorts of nasties in that water supply. And so it was no surprise that back in those days there were many waterborne diseases associated with the water supply system, and it wasn't uncommon for there to be deaths from things such as cholera and typhoid. So this is interesting. This was a picture that was in the paper, the local paper in Adelaide back in 1882, a drop of Adelaide water. So I don't know if you can see the detail from at the back there, but there's all sorts of things in there. So even in the late 1880s, there were, I guess, an appreciation then that the water supply perhaps contained some undesirable elements, things that weren't necessarily good for us. So really out of that there became an increasing awareness that there needed to be something done about our water supply systems to first of all make sure that we had dams in place to collect the water to assure the security of our supplies, but then also some work to make sure that we cleaned the water up. So in the 1860s to 70s was construction of Adelaide's first reservoirs, including the Hope Valley Reservoir. And by 1977, a further 8 reservoirs had been constructed around the Adelaide, to serve the Adelaide metropolitan area. So here's a picture of the Barossa Reservoir Wall, construction in 1902, which many of you will be aware is Whispering Wall. Okay, so into the 1950s, there was a lot of challenges in getting water out to vast areas of the state. So pipelines were constructed, and the construction of the Madam-Adelaide pipeline in 1955 was quite significant in getting water out to several parts of the state. So this really tapped into the River Murray supply and enabled a number of remote regions in the state to settle. So without this water, many of the country towns wouldn't have been able to flourish. So here's some of our other water storages. So the Happy Valley Reservoir, Maiponga Reservoir in the south, and Mount Bold. So I'll just put a question to you, though, about where South Australia's fresh water comes from. So these are the main sources. So we've got the River Murray, rain and reservoirs, so what we collect in our reservoirs, groundwater, and then seawater desalination. So does anyone want to hazard a guess at how much, what contribution the River Murray currently makes to our water supplies? So we've got a range there, I think 20 to 70%. Okay, so it's actually up to 85%. So that's quite a significant amount of water what you consider comes from the River Murray. Now, it does vary depending on how much rainfall we get each year. But when we were in the drought situation back in 2006, we were having to draw from the River Murray quite significantly. And if you think we're at the end of the River Murray system, there's a lot of water that's taken up, further up, and a lot of inputs into the River Murray. That's a big reliance on a scarce resource. Rain and reservoirs only makes up about 8%. So although we've got our dams and we're using our dams to collect rainfall, we do have to, in summer, when we don't have a lot of rainfall, have to supplement those reservoirs with pumping from the River Murray. And that's quite costly to pump. It takes a lot of electricity to pump that water from the River Murray. Groundwater contributes about 7%. Seawater desalination, these figures when I put them together was about 2 years ago, 0.1%, but the desal could actually supply up to 50% of our supplies if we required it. So I won't talk a lot about the desal plant today, but just to mention it's there as an insurance policy if we ever do, and we will. I shouldn't say if we ever. We know we're going to go through drought years again if we do need that, so we don't have such a heavy reliance on the River Murray. Okay, so what are some of the challenges we face in South Australia with our water supplies? Well, I mentioned drought. We've had some rain recently, but we do get droughts, so we don't have a high rainfall in this state. We have that heavy dependence on the River Murray system, and being at the end of the River Murray system means that we have all sorts of challenges from a water quality perspective. It's not the most pristine water supply to be starting with. And there's issues when, during the drought period, we had an increase in salinity. Our catchments are very open to human activities. So we're not like Melbourne. Melbourne have more protected catchments. Our catchments are very much open. We have a high level of agricultural activity in the Mount Lofty Ranges, a lot of forestry, there's farms, there's lots of opportunities for contaminants and chemicals to get into our water supply system. Often we're starting with a very poor water quality in our source waters, and also the fact that we have a lot of above ground pipelines, long pipelines, very hot, dry summers means that it's conducive to the development of algal blooms because we have those unprotected catchments where there's opportunities for nutrients to wash in from farms and various agricultural activity. That combined with the high temperatures and low rainfall is a breeding ground for algae. So algae is one of our biggest challenges over the summer period. So here's just a few examples. So there's lots of creeks and streams that feed into our rivers that then feed into our dams. And when you have cattle that are grazing near them, you have activity around our catchments, they're all opportunities for contaminants to get into our water supply system. So here's a picture of the River Murray when it turned green. So we do have from time to time algal blooms in the River Murray. So this is quite an extreme event. It was about 6 years ago, I think. So when we see that, we know we need to do something about it. Okay, and here you might just be able to see that. This is a picture of Maiponga Reservoir again, it was several years ago. You may just be able to see down the bottom there. This is a scum, an algal scum that was developing. And again, it was over summer. Summer is the time when we have most of these challenges. So I pose a question, would you drink that if you saw that coming out of your tap? I remember when I was a child, I grew up north of Gawler, so we had our water supplied from the Barossa, and I remember I'll just go back there. I remember the bath, if the bath was filled up, that was the colour of it. But then when the filtration plants were constructed, it certainly cleaned things up significantly. So we have to do quite a bit to the water in this state to make sure that we clean it up sufficiently, to make sure that it is safe from a microbiological point of view for drinking. It needs to be treated to make sure it is safe to drink. Disinfection is a really important step. So we use chlorination, so chlorine, and we use monochloramine for some of our systems where there needs to be a longer acting disinfectant. A lot of people don't like the taste of the chlorine in the water. It's funny, it's a perception thing. In the US, if they can't taste chlorine in the water, they're actually quite concerned that the water is not safe to drink, because they like that assurance. If there's chlorine, if they can taste it, they know that it'll kill all the microbes, so it'll be safe from a microbiological point of view. In the 70s to 80s, the construction of the treatment plants played a significant role in cleaning up the source water. Hope Valley was the first filtration plant, and in recent years, in the last 10 years, there's been treatment plants built along the River Murray, which have actually cleaned up the water supplies to the townships around the river. So this is just a little bit of a schematic to show a water supply system at a big picture scale. So we have our catchments where all sorts of activities are happening, collecting water from rainfall. It comes into our dams where we store it. Then we need to treat it. So in the treatment process, there's lots of steps to actually remove a lot of the organic matter that's in the water, to clean that up and take that out as much as possible. And clarification, then we disinfect. And then we have our huge network of pipes across, if we think across Adelaide, there's a huge network of pipes. And at various stages, we have chlorination that is being re-added. So depending on the length of the pipes and the time or detention time that the water is in the pipes, the chlorine will degrade. So we need to make sure that that residual is maintained so that when the water reaches the customer or your home, it is safe to drink. Okay, so that's a bit about the history and some of the challenges that we face, which I thought might provide some context to where the laboratory comes in. So AWQC, the Australian Water Quality Centre, SA Waters Laboratory, we used to be based at Bolivar, but in 2009 moved to the new SA Water House building. So you've probably seen this building on Victoria Square. The laboratories are over 3 levels. The ground floor to the rear of the building, level 1 and level 2 are the laboratories in the building there. So thousands of samples are tested every week. So we're collecting samples every day from right across the state. And those samples come into the laboratory, are tested every week just to make sure that the drinking water supply is safe. And the results of that work are really, really important in terms of fine-tuning what the operations people do out at the treatment plants to make sure that adequate treatment is provided. Okay, many people aren't aware that the labs have actually been around for over 80 years. So it first started out at the Glenelg Sewage Treatment Works. So this is a picture of the Glenelg Sewage Treatment Works. And it was probably back in the 1920s and 30s that there was more and more attention being placed on the public health aspects of water quality. So out of that, there became a need to set up a laboratory to test the water and to test for waterborne or potential contaminants that could cause waterborne disease. So in 1933, the first laboratory was established there. So here's a couple of pictures here of the early laboratory. This was a picture back in the 1930s. This was a picture of where they were doing the microbiological testing in the 1950s. In 1966, when the Bolivar wastewater treatment plant was established, they built a laboratory, all-purpose built laboratory then, and that's where the laboratory moved. So back then the laboratories were responsible for principally testing the sewage and trade waste analysis, but doing some water analysis. And then the laboratory had a very important role to play when the pilot plant operations and investigations were being conducted that led to the construction of the water treatment plants. So there's a couple of photos here from the 1970s of the Bolivar lab. In the 1980s, so by that time, most of the water treatment plants had been constructed that served the Adelaide metropolitan area, and there was a survey conducted to assess, I guess, people's views of the water quality in Adelaide. And despite that massive investment that had been made with all the construction of the treatment plants and the fact that the water was a lot cleaner, still a whopping 76% of people surveyed in Adelaide still believed their water to be up with the worst in the world. So something needed to be done about that. So that was really where the laboratories, I guess, looked at needing to actually set up a centre of excellence. So a centre, first of all, to be doing some research into looking at the water quality, but moreover looking at improved ways of treating the water. So this is where the research centre, the Australian Centre for Water Treatment and Water Quality Research, was established. Back then, when that was set up, and that's when I joined the organisation as a summer research scholarship student while I was still at uni. Back then, it was Don Bursell, who was the state's chief scientist up to about a month ago. We've got a new chief scientist now, but Professor Don Bursell was really instrumental in setting up this centre, and this centre became a centre of excellence across Australia for water quality treatment and research, and then became internationally recognised. So we have a lot to owe to Don Bursell's foresight in actually setting up this centre right here in South Australia and attracting a lot of funding from not only around Australia but internationally as well. So the AWQC today, much more modern than the laboratory of the past, state-of-the-art laboratory, as I mentioned, over 3 levels of SA Waterhouse. We have the research laboratory integrated with the operational laboratory. I manage the operational laboratory services part. A huge range of services that we offer, and we're doing testing not just for SA Water and all water that are operating in this state, but for many of the other water utilities across Australia and even overseas. So there's a lot of expertise that's been built up here, and I guess it's been built up because we've had so many challenges in South Australia, and because of that research centre that was set up in 1987 attracted a lot of funding to do research, to develop new techniques to be able to test the water and to be able to treat the water. And that expertise that's been built up has international recognition. So it sees us serving customers from as far afield as Hong Kong. We're serving Hong Kong Water Supplies Department, Singapore Utilities, and a broad range of clients also across the UK and Europe and Asia for product testing of products that come into contact water. So I think it's good to recognise that this is probably a real success story for the state, and I don't think a lot of people know much about that. They might think the labs do a little bit of testing for SA Water, but it's a much broader service than that. Okay, so as you can see, it provides a very vital service to assuring the quality of South Australians' drinking water. I mentioned in addition to supporting the national water industry and external clients, samples collected from catchment to tap every day. And because we're serving all of the state, we have samples that are flowing in from some of the outer regions, the Eyre region. We've got a sampling team over at Port Lincoln, down in the southeast, and those samples are flowing into the laboratory. Quite often don't reach the laboratory until 6 o'clock at night. We have staff working back until 11 o'clock each night to process those microbiological samples, because a lot of those samples need to be tested within 12 hours of collection. So it's a service. It's not just a 9 to 5 service. It's going into the night to make sure that the water quality is being assured. A very wide range of parameters such as pathogens, algae and chemical components. There's about 1,000 different tests that are offered, and you probably think, wow, are there 1,000 different things that need to be tested in water? There's quite a bit involved in analysing the water supplies. And at any given time, just to give you a feel for the size of the operations, there's about 3,000 samples that are being processed through the laboratory. Around about 700,000 test results a year, and a team of 90 scientists that are working on that. The laboratory services area that I look after is broken up into a field services team. The field services team, we have about 15 staff that go across the state each day and collect water. And they have purpose-built vehicles with mini labs on the back. So as well as collecting samples, they're doing some testing out in the field. And then we have our chemistry services team, our life sciences team, and backed up by our quality and systems and customer services groups. Here's the field services group. So you might be able to see there, this is one of their vehicles. So they're collecting samples from across the state, doing some simple testing in the back of the vehicle. We have what we call a laboratory information management system, or a LIMS system. So when they're out in the field and they're doing their testing, they can enter the results in the field, and that information is uploaded into our overall system, so the operators can already see what the results are. So we're aiming to get the results out as quickly as possible, and that's one way in which we get results out in the field to our operators very, very quickly. Okay, chemistry services, a very broad range of services that they provide, and a lot of sophisticated instrumentation that's used these days to be able to test for a wide range of parameters, to get down to very, very low levels. We're testing to the Australian Drinking Water Guidelines, and we test for the components that are listed, or all the parameters listed in the Australian Drinking Water Guidelines. And SA Water aims not just to meet the guidelines, but to actually achieve water that is better than the guidelines. And we have a number of, systems in place to raise alerts when levels are rising. But the whole idea and philosophy behind the Australian Drinking Water Guidelines framework is to have a very proactive management of the drinking water supply. So you're actually picking things up earlier before they reach guideline levels and doing something about it. This team tests for things such as disinfection byproducts, algal toxins. So occasionally when we have an algal bloom, it might be a bloom that is toxic, produces toxins, so they're testing for toxins. A couple of compounds called MIB and Josmin. You might have tasted the water tasting a little bit earthy and musty from time to time. That's generally caused by Josmin in our water supply, and it's not harmful at all. It's quite harmless. In fact, it's found in beetroot and sweet corn. It gives it that earthy flavour. But when people can taste it in the water, they think there's something wrong with the water. So there's a lot of effort that goes into testing that. Pesticides and herbicides, because we have catchments where we have agricultural activity, there's opportunities for those things to get into the rivers and streams that feed into our waterways. So we're very vigilant in terms of testing all those waterways for those. Okay, so a little bit more about the chemistry services side as well. How am I going for time? I'm running out. So I won't go into a lot of detail with this. Just one thing I wanted to mention, that from time to time there have been water quality issues that we've had to face across the state, and we've done all sorts of things to get the samples to the laboratory very quickly. And this is an example where we got a helicopter to actually fly some samples in from the York Peninsula when there was an algal bloom there in year 2000. So our services are 24-hour, 7-day-a-week service as required if there's emergencies. So, thank you.
Thank you, Karen. I found it very, very interesting. I've heard you before, that's why I asked you to come back, and I've learnt a lot more from it today.
Yes. Yes. Okay, so just for everyone, in case you didn't hear that, the question was around this, the difference between the quality of the water we might collect from the River Murray and desal, the sea, desal. So the desal water a lot cleaner. So we're starting with a cleaner product. The River Murray is very, very turbid. So if you get a glass of water from the River Murray and hold it up, you won't see the light through it all that well. So there's a lot of organic matter in there. And the fact that if you think about all the activity on the River Murray, or what's happening upstream, we've got boats, etc. on there. There's a lot. It's a lovely mix of all sorts of things in there. So desal water, a lot cleaner, a lot easier to clean up. So definitely easier to clean, and from that perspective.
Karen, thank you. As a scientist, and I might be putting you on the spot, is there any correlation between the fact that we've cleaned up our water so well and the increase in allergies and childhood issues these days? As a baby boomer and growing up with bloody awful water through a sand filter at Glenelg, I just wondered, most things I survived, but I'm just wondering if there's any correlation between the two.
That's a good question, and I don't know whether anyone's done any studies on that, but I have heard that there's been connections made with the very clean environments that we live in these days, and the maybe the focus on cleaning around the home and having things ultra clean, and that what that does is doesn't expose children's immune systems to as many bugs and contaminants that would then build their immune system. Now, I don't know whether anyone's done any studies with the water. You could draw a parallel with that as well, possibly, yes.
Tell me, are you testing for asbestos? Because during the 40s and 50s, there were many asbestos pipes laid, and I doubt or I know they haven't been picked up from where I know they are.
Yes.
So I just wonder what the result is from drinking water that comes from asbestos pipes.
Yes, we do test for asbestos. That's one of the tests that we test for. So we do, yes. Yep. Yes. Yeah. Oh, okay. Good question, and I'm afraid I'm not qualified to answer that. So most of the groundwater is it's down the south and state and the Eyre Peninsula. I think it's a heavy reliance on the groundwater there. There's more water to take, that's for sure, but I'm afraid I can't answer. I don't know the quantity on that, sorry. Yes. 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 That's right. So that's geosmin. So geosmin causes an earthy, musty, grassy flavour. People will pick it up a little bit differently. And some people are very sensitive to it. And you can pick it up at very low levels. Most people will pick it up at around about 10 nanograms per litre. So that's 10 to the minus 9 grams per litre. So it's very, very, very low concentrations. Now, it's not harmful at all. It occurs naturally in food, certain foods, as I mentioned, but people don't like the taste of it and smell it because it has that earthy smell. They think something's wrong with the water. Now, it can come from algae. That's where we principally find it coming in from. So there's quite a bit of work done to actually look at the levels of geosmin, and what we can do is put activated carbon on at our treatment plants. So if there are any issues that we find in the water supply system, any contaminants, activated carbon is normally what we put on at the treatment plants to remove or reduce the levels of some of these parameters. Yeah. Yeah. I don't mind it, you know, and we have taste panels we have taste panels. We don't taste wine, we taste water from time to time, and it's interesting because every year our taste panel goes through training, and some people are very sensitive to it and others aren't, and MIB is the other one that causes a musty smell as well, but geosmin's more readily occurring. And I quite like Josmin because it reminds me of all sorts of things. I pick up the grassiness of it, so cut grass or earth or playing in the garden, that reminds me of that, so I like it. Okay, so the question was whether Beetaloo Reservoir is still used. I don't think it is, but I might need to check on that one. Yeah. Okay, so rainwater tanks. Okay, so rainwater, if you think about where you're collecting it from, so your roofs, gutters, important to make sure you keep your gutters clean, but I guess some of the challenges you might have, so certainly the paper will remove any gross things in your water, but the potential issue will be pathogens, so bacteria. So if you've got birds doing droppings and things on the roof, you might want to boil your water for drinking purposes. But having said that, I grew up partly on drinking rainwater as well in the country, and I think your immune system builds up to what your local bugs are and things in the water. So if you've been drinking it for many years and you don't have any ill effects, you're probably okay with it. But as an extra assurance, boiling the water would be a good idea because it doesn't contain a disinfectant. So the activated carbon will remove chemicals. So there's things from pollution that would land on your roof and come in. So the activated carbon would remove that, but it won't necessarily remove your pathogens, your bacteria. So boiling, it's a good idea.
Thank you, Karen.
Okay, thank you.
Something
Thank
to
you.
take away with you.
Thank you very much.
And thank you very much.
Thank you.
Very
Thank you.
interesting.
Thanks.